Number 21. If Mars is approximately 2.24 times 10 to the 8th kilometers from the Sun, we want to find the distance from Mars to the Sun in miles. We're going to use the fact that 1 kilometer is 6.21 times 10 to the negative 1 miles. So when we want to do this type of conversion, we're just going to multiply 2.24 times 10 to the 8th all times 6.21 times 10 to the minus 1. So anytime you're multiplying in scientific notation, we start by just multiplying the numbers. 2.24 times 6.21 is going to be 13.91 times 10 to the, our exponent is found by adding exponents, so 8 plus negative 1 is 7. And this number is not currently in scientific notation. In order to be in scientific notation, the number needs to be between 1 and 10. Currently 13 is not between 1 and 10, so we need to move the decimal place once. And then we still have this times 10 to the 7th. Multiplying these exponents is going to mean adding, so 1 plus 7 is 8. So 1.391 times 10 to the 8. Number 22. Supply is the amount of a specific product available for purchase. Demand is the consumer's desire and willingness to pay a certain price for the product. Suppose that QS represents the quantity of plasma TVs supplied and QD represents the quantity of plasma TVs demanded at a store. So the equations below show how the quantity is related to the price of a plasma TV. The equilibrium price is defined as the price at which the quantity supplied equals quantity demanded. We want to find the equilibrium price. The part that's underlined tells us exactly what we want to do. We want to take the quantity supplied, which is 1.5p minus 1,000, and we want this to equal the quantity demanded, negative 0.5p plus 2,000. And so now it's just a matter of solving this equation. We want our variables on the same side, so I'm going to add 0.5p to both sides. This is 2p minus 1,000 is equal to 2,000. We now want our constants on the same side, so I'll add 1,000 to both sides. So we get that 2p is equal to 3,000. Dividing both sides by 2 gives us the final answer. The price needs to be 1,500. So this is the equilibrium price. The quantity supplied is equal to the quantity demanded at this price. Number 23. Andy has 20 coins made up of quarters and half dollars, and their total value is $6.50. How many quarters does he have? So the first thing it tells us is he has 20 total coins. So if I take the number of quarters plus the number of half dollars, this should be equal to 20. The next thing we know is their price. Well, quarters are worth 25 cents, and half dollars would be worth 50 cents. And this should be equal to the total amount we have. We're going to solve this using elimination. And it's very important to note here that we only want to know how many quarters he has. We don't really care about the half dollars, so let's eliminate H. So I'm going to multiply this first one by negative 0.50. So I get minus 0.50Q minus 0.50H is equal to minus 10. The second equation I'm going to leave alone. I'm going to get 0.25Q plus 0.50H is equal to 6.50. Our H's cancel. Minus 0.5 plus 0.25 is negative 0.25Q. The negative 10 plus 650 is negative 350. Dividing both sides by negative 0.25 gives the Q, the number of quarters, is equal to 14. So Andy has 14 quarters. It doesn't ask, but you can determine that he also has 6 half dollars. A plane travels 5 hours against a 40-mile-per-hour headwind. The return trip going with the tailwind only took 3 hours. Find the speed of the plane in still air. So this is going to be a distance, rate, time problem. So we'll set up a chart. So first, we took 5 hours against a 40-mile-per-hour headwind. So against the wind is going to slow us down. So R minus 40. The return trip only took 3 hours. So with the tailwind means we're going to go a little faster. We're going to get R plus 40. The distance, well, we just took a trip and then we turned right back around. So the distance will be the same. So my equations here, distance is equal to rate times time. If I simplify this, I get 5R minus 200. The second equation would be distance is equal to rate times time. And if I simplify this one, 3R plus 120. So now I have two equations. And so I can solve for R, the rate, which is what I want to know, their speed. I have that the distance is 5R minus 200. And then it's also 3R plus 120. We want to get the variables on the same side, so I'll subtract 3R. That gives 2R minus 200 is equal to 120. Adding 200 to both sides to get the constants on the same side, I get that 2R is equal to 320. We need the R by itself, so we'll divide both sides by 2 to get that R is equal to 160. So the speed of the plane in still air is 160 miles per hour. 25. Natalia invests part of her $10,050 lottery winnings in a savings account and places the rest in her checking account. If she places $250 more than twice her savings deposit into her checking account, how much did she place into each account? So the first thing to note here is that all of it went to either savings or checkings for the total of $10,050. The second sentence gives us the other equation. 250 more than means plus, twice her savings deposit went into her checking. So now we have two equations. Since the second one has C equal, we're going to use substitution. So my first equation says S plus C, but instead of C, I'm going to write 250 plus 2S. And this should be equal to 10,050. I have an S plus 2S, so that's a 3S plus 250 is equal to 10,050. I'm going to subtract 250 from both sides to get my constants on one side and variables on the other. So $10,050 minus $250 is $9,800. At this point, we'll divide both sides by 3. And this gives us the amount she deposited into her savings account, which is $3,266.67. Now we need to know how much went into her checking. Well, I know that the savings plus the checking is equal to her entire money, $10,050. Subtracting 3,266.67 from both sides gives us the amount in her checking, which is $6,783.33. 26. Antoine and Lila are selling candy bars for a school fundraiser. Antoine is selling bars for $2 each, and Lila is selling bars for $2.50 each. If together they collect 317 bars and collect $711.50 from these sales, how many candy bars did Lila sell? Well, one thing we know is that there was a total of 317 bars. So if I add these two, I should get 317. The other one comes from the price. So Antoine is selling his for $2 and Lila's selling hers for $2.50. And this should be equal to the total amount that we got, $711.50. The question wants to know how many candy bars Lila sold, so we're going to try to eliminate A. So I'm going to multiply the first equation by -2. -2A minus 2L is equal to 317 times -2, which is -634. The second equation I'm going to leave alone. 2A plus 2.50L is equal to 711.50. So now my A's are going to cancel each other out. I get 0.5, messed that up, 0.50L is equal to 77.5. Dividing both sides by 0.50 gives us the amount of candy bars Lila sold, which is 155. 27. Two cars leave town at the same time, heading in the same direction. One travels at 40 miles per hour and the other travels at 30 miles per hour. After how many hours will the cars be 50 miles apart? So this is another distance, rate, and time problem. So we have two cars. The first thing to note is that they leave town at the same time, so they've been traveling for the same amount of time. One is going 40 and the other one's going 30. We want to know after how many hours will they be 50 miles per hour or 50 miles apart. The one that's going 40 miles per hour is going to be ahead of the other one. So he traveled some distance plus an extra 50 miles. The other one just traveled D. So this puts car 1 50 miles ahead. So now my first equation, distance equals rate times time. And the second equation, distance equals rate times time. This one we're going to solve by using substitution. So D is 30t, and then plus 50 should be equal to 40t. We want to get our variables on the same side, so we'll subtract 30t from both sides. This gives 50 is equal to 10t. Divide both sides by 10, and you get 5 is equal to t. So these cars will be 50 miles apart after 5 hours. 28. Ellen wishes to mix candy worth $2.05 per pound with candy worth $3.61 per pound to form 32 pounds of a mixture worth $3.02 per pound. How many pounds of the more expensive candy should she use? So first off, if we take the first candy and add the second one, we want to total up 32 pounds of candy. The second thing we know is their price. 2.05 times how many pounds we have of candy 1 plus 3.61 times how many pounds we have of candy 2 should be equal to 3.02 times how many pounds we have of the mixture. So I'm going to go ahead and simplify this. Actually, I'm going to go ahead and multiply it by 100 as well to get rid of the decimal. So I have 205x plus 361y is equal to 3.02 times 32 times 100, which is 9664. I'm going to go ahead and rewrite this second equation, or the first equation underneath it, just to make things simple and organized. So now we want to eliminate something. And you'll notice the problem specifically says how much of the more expensive candy should she use. So we're going to eliminate the first variable, the first candy, the less expensive one, because we don't really care about that one. So minus 205 times the second equation. That gives me minus 205x minus 205y, and then 32 times negative 205 is going to be negative 6560. So adding these two equations up, 361 minus 205 gives us 156y, and then 9664 minus 6560 gives us 3104. Dividing both sides by 156 gives me that I need a total of 19.9 pounds of candy. Number 29 wants us to solve a system by graphing. So let's start graphing the first line. 3x plus 2y equal to 18. Let's start by letting x be equal to 0. This gives us 3 times 0 plus 2y equal to 18. So that gives us 2y equal to 18, and dividing both sides by 2 gives that y is 9. So we can graph this point, 0, 9. So first we need to define our axes. It's kind of hard to draw a straight line here, but you'll be able to get the general idea. So over 0 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here. The next thing we should do is try to let y be equal to 0. That gives us 3x plus 2, 0 is equal to 18. So 3x is equal to 18. And dividing both sides by 3 gives me that x is equal to 6. So here I would have 1, 2, 3, 4, 5, 6, and then up 0. And we can connect these two dots to get the general line. The next equation is going to be a little bit trickier. This time I'm going to solve for y to start with. So I'm going to add 4y to both sides. That gives me 3x is equal to 4y. And then I'll divide both sides by 4. So I have 3 over 4x is equal to y. We have that our y-intercept is 0, 0, since there's no plus another number. And the slope is 3 over 4, so from this point we should go up 3 and over 4. And that gives us the second point, and we can draw the line between them. Wherever they intersect is going to be the solution. My picture here is definitely far from perfect, so my intersection point is actually not right. But you do get the general idea. If you do want to solve anything by graphing, you do need to make sure your lines are perfect, much more perfect than mine are here. 30. The moon is approximately 238,900 miles from Earth. Venus is approximately 23,612,100 miles from Earth. Assume that the moon, Earth, and Venus are all on the same straight line. How long in hours would it take a space shuttle traveling at 6,400 miles per hour to fly from the moon to Venus? So this one does come with a little bit of a picture. We have the Earth. We then have the moon. And then way out here we have Venus. We know the distance between the moon and the Earth. So this distance here is 238,900. We also know the distance between Earth and Venus, so the long distance. This is 23,612,100 miles. So we want to actually look at the moon to Venus. So the first step would be to find this distance. And we're going to do that by subtracting 23,612,100 minus 238,900. So this will give us the distance between the moon and Venus, which isn't currently given in the problem. And we get 23,373,200. We do want to convert this to scientific notation. So then we move the decimal place 1, 2, 3, 4, 5, 6, 7. So 2.337, I'm going to round here, times 10 to the 7th. We also know that the space shuttle is traveling at 6,400 miles per hour. So this one here is going to be equal to the distance. Our rate is 6,400, which, if we want to put this in scientific notation, 6.4 times 10 to the 3. So we actually want to find the time, how long in hours. So we know distance is equal to rate times time. So we have the distance is equal to the rate times time. So we're going to divide by the number in front of t, which is 6.4 times 10 to the 3rd. So since we're dealing with scientific notation here, we're going to start with dealing with just the numbers. 2.337 divided by 6.4. That gives us 0.3652. We then are going to deal with our exponents. Anytime you're dividing, we subtract exponents. 7 minus 3 is 4. This number is not currently in scientific notation. We're going to need to move the decimal place once to the right. So that adds an exponent of -1. So now I have -1 plus 4 would give me my final exponent of 3.